Hello and welcome to the Enterprise Talk Conversation Series, a peer knowledge resource by the CXOs for the CXOs. Now to our host, Kanika Goswami.
Hello and welcome to our podcast On Stage with Enterprise Thought Leaders. Today we have as our guest Padma Sundaram. She's the Director of Software at General Motors. She's a strategic thinker, an emergent leader, and an effective team builder. Welcome to our show, Padma. It's great to have you with us today.
Hey, good morning. Thanks for having me.
Oh, it's a pleasure. I'm really looking forward to speaking with you because after having read up a bit about you, I'm really excited to talk to you about the kind of work you do and the kind of work you can do, which I think a bit of it is covered in her profile that we've received from them. Padma is an experienced thought leader and a passionate a technologist about applying technology, artificial intelligence, and automation to help improve product safety and user experience in the field of automobiles. With over 24 years of specialized automation to help improve with over 24 years of specialized technical and people leadership experience in the industry and its engineering systems, software, safety, and technology innovations, Padma is currently leading the execution of GM's software-defined vehicle governance, virtualization, and digital operations. Quite a mouthful, and I would like it if you could, explain it to us in some terms that we can understand, a little easier, Padma, if that's okay with you.
Absolutely. Hey, first of all, thanks again. Thanks for having me. It's nice to talk to you about what I do. So I am the director for software-defined vehicle operations, and this includes end-to-end platform operations for the General Motors software-defined vehicle, including virtualization, which has emulation, simulation models that enable faster digital development. And it also has certification process, certification of the software that will be deployed over the air. And I also have end-to-end governance on the over-the-air process itself, development and deployment of over-the-air. And then I also oversee end-to-end cloud operations, cloud infrastructure, all of the architecture that happens in the cloud. And most importantly, the CI/CD pipeline, and we infuse the cloud native technology into the CI/CD pipeline. So all of this becomes part of the operations. And then once you deploy the vehicles, we have to make sure we are monitoring the vehicles and we are able to fix any issues or self-heal, quickly mitigate things. So I also have the digital feedback loop called as the Altify feedback loop that is also part of the operations. So that is what comprises the end-to-end operations.
That's great to know, and I think it's much easier to understand now that you put it this way. So I wanted to do a bit of introduction about General Motors, but I don't think it really needs any introduction to anybody in the in the enterprise world. It's among the first companies to successfully transcend the mobility revolution and to lead the industry's transformation from hardware-centric to a digital platform-based, software-defined and service-oriented vehicles using AI or software automation, virtualization, HPC, and connectivity. And that is exactly what you told us that you are responsible for. So we're speaking to the right person to talk about GM being future ready for various kinds of ideas we have about what automotives are going to be in the next decade. But my first question will not be about technology, Padma, if you pardon my how should I put this, being a little precocious here. We haven't shared this question with you, but I'm sure you'll be ready with an answer. A woman in a technology leadership position, do you think General Motors sees diversity as an intrinsic part of their evolution, or you just happen to be there because you're just so good at what you do? Which do you think is correct in in your context?
I think it's both of those. I happen to be at the right place at the right time, and I also have been very fortunate to have fantastic leaders, mentors, guides at General Motors. I'm coming to about 17 years at GM, but prior to that, I was still associated with the GM family at Hughes Aircraft and at Delphi. And along the way, the culture in GM is all about diversity. In fact, I think last year, you can see the GM CEO put out our vision of being the most inclusive company in the world. And we are striving towards that.
And
So,
she's also a lady, right? You have a lady CEO,
yes,
right?
Mary Barrow is this, yeah, she's a
Correct.
fantastic leader.
That's really good to know. We are headed in the right direction and we are in safe hands, if I can say that. Okay, so now my first question is what strategies will you suggest to development teams to reduce the gaps between software and hardware and deliver an enhanced user experience going forward?
That's a very good question. With software-defined vehicle, what we're trying to do is decouple software from hardware because traditionally vehicles automakers always had hardware-driven development and hardware dictated what kind of software and how much software and things like that. And so now that we are venturing into software-defined vehicle, we have to decouple software from hardware. That way, we can allow software to iterate and evolve and provide enhanced functionality continuously to the vehicles. But decoupling software and hardware does not mean that we disconnect. Both have to talk to each other and both have to work together and they have to be compatible. So some of the key things that we have learned over several years now, working with Cruise, working within GM as well on some of these enhanced products, is upfront collaboration between the software and hardware teams. Upfront collaboration where there is a shared MVP, shared vision on what your goals are, both the final goal and the interim goals, and you're all sharing a common backlog. That way, everybody knows what's coming next, and you're all working towards that. And then you may be working decoupled, but you have to work in parallel. You have to make sure you have an eye on the architecture. Both the teams should have an eye on the architecture and make sure that you have regular syncs between the teams so that you want to ensure that the architecture that's being defined is compatible with the software. And then adopt technologies, exploit the technologies that are there, apply emulations, simulations to make sure that you're iteratively testing this combination of software and hardware capabilities to make sure that everything is compatible, everything is working as intended. And it goes without saying collaboration at all levels. That's the key here. Decouplement does not mean disconnect. Decouplement means more collaboration. It's just that you're reducing the dependencies between hardware and software.
How can legacy hardware based businesses embrace the latest software solutions to enhance their operations? What's the kind of challenges that technology leaders face there during that transition?
That is a fantastic question because as we venture, as we are getting into the software-defined vehicle development, you're going to have legacy organizations, legacy software, legacy information technology structures. Now you have to make sure that they are compatible and they are transformed to support the software-defined vehicle. And some of the things that we are doing and we are continuing to learn. Now I'll just say that we are also in the journey right now, but I'll share what's working. And we have learned a lot with our 6 years engagement with Cruise. And we have learned a lot what works, what doesn't work. And so we have that advantage as we get into the software-defined vehicle development. And we definitely think that the legacy areas should start adopting cloud technologies. Now, I don't want to get into the details of it. Definitely considering containers, things like that, to manage legacy software. You want to also think about how do you want to develop software in this space, in the legacy software space. You want to adopt DevOps type of environment and agile software development space with cloud native CI/CD pipelines for software development, applying technologies that we just talked about, automation, virtualization, and a microservices based architecture for a healthy management. You want to be able to quickly turn around something. You want to be able to continuously update and release software for faster deployment, microservices based architecture and a software approach that goes with that. And then, of course, as you have pieces of software that have to interface, adopting healthy APIs that are standardized and that can integrate well and work well, and those have to be tested. These are some of the things that we think are good place to start.
Right. And what cultural shifts would you suggest or In your experience, what kind of cultural shifts would be really good for development teams to decouple software from hardware to to deliver the efficiency that this activity is supposed to require?
Yeah, culture, when you talk about software-defined vehicle, culture among the development teams and the culture that we have in the company definitely is one of the big challenges because it's a paradigm shift moving away from hardware driven to software. So setting up the right culture absolutely is critical for the success. And some things that we have learned that enables this is to work like a startup, create a startup like mindset where you're able to be nimble, where you're able to be flexible, you're quickly able to adapt to the changes, smaller teams that are empowered with a flatter leadership structure that can enable faster decisions. And you also always want to create an environment of learning. And what I mean by that is we have to, because we are in the unprecedented space, there are things that we are doing that we have never done before. And so you are exploring constantly. So when you're exploring and experimenting, you're not going to be successful all the time. So you should be tolerant to failures. You should, in fact, we think we would like to fail early and learn from it and grow from it. And so this culture should allow that, allow learning. And at the same time, I'll also say this, you also have to have a culture that is unlearning. That means there will be things that no longer apply to the new space. In this, historically, there are certain things that you have done, traditionally, certain things that you have, processes and methods that you have applied, and that may not apply in the new space. And so you will have to be bold enough to challenge the status quo and do what is meaningful. So learning and unlearning is absolutely critical, and creating that culture of teams to work together, learn from what is being discovered, and growing from that. And another thing is you also want to make sure you're continuously creating a culture of innovation. You're continuously reinventing, and learning and growing from that. These are the things that we think uh, will will help as we venture from the traditional software development space to a more agile software-defined vehicle development space.
Yeah, and speaking of software defined, would you be able to share with us in a slightly um, um, understandable terms, if I may use that word, what the latest technologies are that are being used in software defined vehicles, especially the ones that are being made with, as a part of your deliverables?
Yeah, I think I'll start with the hardware side of it. The high performance compute, smart sensors, intelligent actuators. These are some of the key pieces for the software-defined vehicle. And then the connectivity, broadband, low latency connectivity. 5G is an example for it. That's also critical. And then on the software side, and enabling the integrated development and deployment, cloud-based technologies, cloud native development environment, and an agile software development process that follows a DevOps type of approach. And you also want to have an integration and continuous testing through virtualization, through emulators, simulators, and then once you have tested enough, you will be deploying it through over-the-air technology to the vehicle, and the vehicle is connected always to the cloud. So these are some of the technologies that are, critical enablers for the vehicle, and being able to also see how the vehicle is performing, how the features are being used by the customer, and then learning insights. Making sure that the features that you're providing are behaving as intended and are useful to the customer, and continuously learning and improving that through the digital feedback loop and data analytics pipeline. So these are some of the technologies that are critical for a successful execution of software-defined vehicle.
And that was very well explained for people who are not technology experts like us. And I'm sure, our audiences are doing better than that. How do businesses leverage digital twin solutions to enable SDV development, validation, as well as deployment?
This is a very good question. I'm passionate about digital twin, and historically, I've been very much in my past involved in applying simulation for safety analysis technologies, like hazard analysis being done in simulation, things like that. And it allows you to do a lot more in simulation than in the real world with a real vehicle. So digital twin basically is a virtual representation of your physical asset. It could be a process, it could be a system, it could be a component, it could be anything. It's a virtual digital representation of it. And the key thing is it is in real time and it's in cloud and it is fed real-time data from the vehicle and from your asset. And it's continuously living twin of your physical asset. And what we can do with that is you are able to apply it during the early design phases. You are able to apply it during development. You are able to apply it during the build phase, manufacturing phase, deployment phase, and also post-deployment, continuous operations, maintenance, and end of the life of the vehicle, even during decommissioning of some of these technologies. So it's going to benefit you from an entire life cycle of the product. And you can, using the data from the physical asset, you can run tons of simulation with the digital twin and gain insights and make very good decisions and be able to influence and recalibrate your design and continuously improve your performance of the product. So that's why it's so powerful. It's so powerful. And it's something that I think will be necessary for some of these technologies, which require tremendous amount of exposure and testing, like the autonomous vehicle space, where you want to test every edge case. You can do that. You can be able to do that. And so it's a very powerful tool. And I think it's also an essential tool in the software-defined vehicle space.
That was interesting to know. And before I go to the last question, I have, one small question which will probably, you will be able to answer it from your knowledge of the industry as such. How does the world automotive industry stand in terms of a proper adoption of software and, what we laymen would probably look at a driverless car or a completely automated machine or, situations like that, which are not very, very, how should I put this, fully adopted by passenger consumers as of now. Where are we? How much time do you think it would be before, it becomes a complete reality in terms of the cars we drive today, you know?
Okay, I just want to say that software is not new to vehicles. If you look at the last 2 decades, I started when software started creeping into vehicles gradually, from the first electronic throttle control system to the electric power steering, electronic brakes, stability control, roll control, wheel dynamics control, and active safety features with collision imminent braking, lane keep assist, and lane centering technologies. And so many of the other passive safety vehicle features as well, like with airbags and seat belts and all the things that are in between. So software is not new, Kanika, in the vehicle. Today, if you take an advanced vehicle, even that is not software defined, you will see 150 million lines of code that's already operating in software. And that is the vehicle that people are driving right now. So in terms of adoption, people have already adopted. And if you look at technologies like our Super Cruise, that's a level 2 automated driving system. It's a driving assist system. That is very well received by our customer base, and we continue to expand the capabilities of that. Now, what will happen is we are trying to take the experience of the software to the new level, where we are able to connect better with the digital lives of the users. We're going to be able to automate more things, like autonomous driving. That's already there today with our cruise autonomous vehicles. And so what we're trying to do is continuously make it easy for not just for the users to use these vehicles, but also for us to continuously improve and add on new features and new capabilities through over the air, where the user doesn't have to take the vehicle to the dealer. We'll be able to do it over the air wherever the car is. And we can continuously provide a suite of features, suite of apps and services for the users to download according to whatever they want and be able to be engaged in their user experience and be able to help make this vehicle an extension of their digital lives. That's our goal. Complement it and extend it. So I think gradually, as the performance of these vehicles are experienced by the users, I think the technology will be accepted. Just like your smartphones, as you started using it, you have started accepting it, and you're starting now. There are a lot of dependencies as well. People depend on some of these features from the smartphones. So similarly, there will be a trend where as these features get into these vehicles and people start experiencing it, the way it interacts with the user and the way it provides an enhanced user experience, you'll see similar trend of users accepting it more and also getting dependent on it.
Yes, and I think the example of the mobile phone that you gave, is extremely relevant here, because most of us who are not on that, users of or drivers of car of that advanced level probably relate to it better. But then another question comes to mind, Padma, and this is also a little bit, out of the curriculum, so to speak. The more digitization happens and the more software development and software dependencies happen, do you also see a higher risk of kind of security, cyber security, data security kind of stuff? How do you handle that? Your platform is, going to be end-to-end software related. It's an SDN platform, but sorry. What kind of security measures do you keep in place so that the passenger data and stuff like that is not exposed for threats and hackers?
Absolutely. One of the things we treat software development and system integrated development very seriously. Let's just take, the autonomous vehicle up front. One of the things that come into play is safety and security. And these are critical criteria for considerations of the architecture. So we bake safety and security requirements into the hardware. We bake it into the hardware. So it's part of the DNA of the system. Same thing with SDV. We consider it upfront. We design the safety and security requirements so that safety and security are built into the design itself. And you want to make sure that you are upfront as part of this considerations, doing all the safety analysis, hazard analysis, security threat analysis to understand potentially what the risk is. And then our goal would be to design the hazard out or the threat out in the design. And if possible, we definitely do that. But in many cases, functionality will have to compete with some level of risk. In those situations, we make sure that the risk is mitigated to an acceptable level through design considerations, both hardware design and software design considerations, and make sure that the product is always meeting the safety criteria, the security criteria. And these standards are built into the hardware and software that we build.
That's good to know, because that's a kind of doubt most people would have with a fully automated or highly dependent on software kind of a machinery. But yes, of course, we're talking about GM here, so there will be no doubt on the kind of software that will go in there. Now, it's a kind of a banal question that I'm bringing up for you, but I'm sure you will have information enough to be able to share some insights with us. How can engineers ensure safety and security while developing codes for the software for the platform? So, as you just said, that it is embedded into it right from the beginning, from the design stage or whatever. So, what role do coders have to play from the basic code? How is security embedded into it?
Right. So we have a team of safety engineers and security engineers that work with software developers and hardware developers. And this happens very early in the process when the architecture is still being defined. And safety analysis leads to several safety requirements. Similarly, security analysis leads to several security requirements. And both these teams, safety, security, are working with the architecture team, hardware team, software team, and the integration team to ensure that these requirements are translated into appropriate design and iteratively tested to make sure that your requirements are sufficient, your requirements are adequate. And continuously, this happens through the development of the process, development of the product. Entire development from concept, going into the requirements phase, going into the design phase, going into the implementation, integration, and validation. The safety and security teams are involved with the developing teams, developer teams, and making sure that at all times the requirements are being met, and we are able to have a safety case, a security case that says that the product meets the requirements. And that's how it works. It works with collaboration, with strong collaboration between the safety and security team, with the broad developer communities, whether it's software, hardware, architecture, validation, integration, all of these things.
So you're saying security has to be in the DNA of whatever kind of development that's happening for the product, right?
Absolutely. It cannot be a band-aid. It cannot be a patch. It has to be something that has to be built in.
Yeah, and because of human lives involved or human data involved, it cannot be an afterthought as well. Yes, so thank you so much, Padma, for your time, and I sincerely apologize for pushing 2-3 new questions to you, which you may not have been prepared for, but I'm extremely grateful that you answered them so well and explained it so well to us. Thank you so much.
Absolutely. Hey, I had so much fun. I just would say this: it is an exciting time to be in the automotive industry, and if for the listeners, if you love working with technology and applying technology to improve the experience, and you love working with cars, check out GM. Come join GM. I think it's a fantastic time to be part of the automotive space.
Oh, that sounds like a great plan. I'm sure a lot of people will be very interested. We're talking about GM after all. It's not just anything. So I'm sure it will be an interesting proposition. Let us hope you hear from some of our audiences. They are also in leadership positions across the globe. It will be really interesting if you can, team up and bring up better stuff than you already do. Thanks, Padma, and good night from Kanika.
Thank you so much.
Thank you so much for being with us. Please do follow us on social media for regular updates and new content.